So, as I already indicated in the first presentation, we will now focus more on our light control solutions and light management solutions. So the first one is in fact a local solution, which is very well adapted when you have walking paths or cycling paths. And so this is now becoming very popular. COVID helped us a little bit over there, because now in every country, cycling is becoming more popular. And there are big investments from cities to improve the infrastructure, and especially to create individual infrastructure for cycling paths. So, and including, which is good for us, individual lighting. So there we have a solution which is called Sensicity. The basis is in fact a sensor. You can see it here, how it is mounted. On the light pole, you can mount it directly. So this is in fact the Sensicity sensor. It has an infrared detector, and as soon as it detects somebody, then it will light up. So it has multiple functions. On the one side, it is connected to the DALI driver, via two wires to the driver of the luminaire. So that means it will boost the light. So you can program it. I will show it to you, that you want to go from 10% to 80%, for example, for 30 seconds. And so this device will communicate that with the luminaire, and it will certainly be more lighting. Next to it, we also have integrated that's technical, private LoRaWAN technology, so that it also can communicate to its neighbors. So it will boost the light, but also you will see you can group a number of light poles together, and then you can say, for example, now I want 5 light poles to go up for 30 seconds to 80%. It was installed last year in the city of Albertslund. You know, Denmark, I think, is one of the most advanced countries when it comes to biking. So they have what they call the super cycle steer. It's the super highway, which goes up to almost more than 50 kilometers out of Copenhagen. And so now, this is very interesting for us, it was installed on part of it. They had, for security, they had 50% on at night, if there was a bike coming. So we implemented it. They changed the programming to 10%. I do not recommend 0% because you don't know where is the cycling, but this was in a nature area. And in fact, indeed, when there was a detection, they switched on 5 light poles, and it goes on. It continues, of course, it's a dynamic system, to 80% during 30 seconds. They saved 72% of electricity. And if they measured also with no light, they went to 80% savings, only during that nighttime. So, of course, with the current electricity price, it's a good investment if there is the money. Most of the cities now are in problem that they have to pay their electricity bill. So it's a little bit an difficult situation, but okay. So next to our SIR, we also have what we call a NOT. And this is exactly the same technology, but it does not have a sensor. So if you want to save some money, or if you have a different application, for example, a parking, you could, in fact, at the entrance of a parking, put a sensor, but on the rest, you can put a NOT. So a NOT will receive instructions from the SIR, boost your light. It's in one group, it will do exactly the same. And then we have a third component, which is very similar to that, which means it's called a VIA relay, because it's connected to a third-party sensor via a dry contact. So that means you could say, okay, if a weather sensor says now it's too bad, switch on the light, it will give a dry contact, the relay will close, and it will instruct all its neighbors to say, now follow the program, and also the light will go on. It's very convenient because I don't know, many people and many companies use infrared, but infrared has some speed limitations. Above 40, 45 kilometers an hour, it's very difficult even to detect with infrared. So that's why you will see one application which is very convenient, that also we have the possibility to add a radar, which can of course go to 120 kilometers if needed, so that we can detect the vehicle, and based on the detection, we can switch on the light. We have a very nice application in Belgium around the port, where it lights up the port area when a car is coming. Please. So here you see in live, so I think it's pretty aesthetic. It's not so big. This is how it looks with the cable. You have the two power cables and you have the two dolly wires. Again, of course, you can either buy it as a standalone product, or we also offer it in a package. It's called with a junction box, with the connectors, and with protection only for that device. So that's an option you have to include. Detection range is almost half a circle of 10 meters. But we have artifacts in which we can limit it. We can make it like that or like that, depending on if you would have a pedestrian crossing, then you would probably prefer to have it so that you don't detect too much pedestrians passing by.
There is a question from audience.
Yes?
What happens if the sensor fails?
Okay, if the sensor fails, with all our sensors, it goes automatically on, light on. So it is, if the sensor is failing, inside the whole installation, and also with our Zagas, NEMAs, we have opted to have instruction to switch on the light at 100%. So that's the standard option. You don't or be without light, but of course you're losing some money, because then light will be on all night, and of course it is depending on here it is depending on also the others that are sending. But if you see one light pole 100% and the other ones are still normally functioning 10% when no bike, and then you know that there is a problem over there. So, in fact, what do you need else? A dongle. So we deliver a dongle, and in fact, inside the dongle there is the LoRaWAN module to communicate, and there is a GPS. So you put it on your favorite tablet, you download for free the software, and in fact, first thing, you open the software, you go on site, you go to each light pole and you set add point. So it opens automatically the Google Maps map, and you set add point. So when in fact you go to each light point, it's a local system, and you make a map, and all those points will be simple dots. Then you can go back to the office, and then you can start programming. The first thing, of course, you will do is make groups. And to each light point, you can attach 4 groups. You will say, if I have one detection there, these 5 should go. And you can make 4 different programmings. And then you see here, the programming, it's very simple, you just slide. So you have 2 types of programming, the boost. I see a bike, or I see a pedestrian, so you slide, do I want 10%, 50, 100%? And how long? Up to 30 minutes, okay, and this is programming the boost, that's it, for that group. And then also it allows you to have scheduled dimming when there is no detection. So that means with the DALI connection, you can have, let's say, saying from sunset, okay, I want 20%. When it is 12 o'clock, I want 10%. So this is all possible to program with this. You do it in the office. You go back, you push the other button, send program, one time, and then the whole system is programmed.
There is again a question
Yes?
that we already talked yesterday, and
Yes.
the question is where the data is saved. It's in your cloud, your server,
Okay, so
because
as I said, it's local. It's not connected. So there is no data gathering. We don't count. It is changing. We will make it connected via our cabinet control system. So there is a new module that will be come to the market, where also this LoRaWAN is, and then we will be able to collect data. So it's really used for the moment now. There are thousands of it installed, but it's local, standalone, not connected. That's the main difference with the next solution, which is more for street lights into the city. Okay? These are some applications. You see, we have a bicycle path, and then there are different groups identified. And in fact, so we have 19 groups of 3 lights. So each time you pass, 3 lights will switch on. And then if you go to the next, it will switch on more. So it's a kind of dynamic lighting, but not continuous. You will see a continuous lighting in the next product line. So very nice application of the radar. We use it a lot on, for example, tramway stations, on more on tramway stations. So light is down, minimal, when there is nothing happening. Passengers are waiting. Tram is arriving. The via relay is activated, and the lights goes up. We know how long it will take here. For example, half a minute before it arrives. We switch on the lights. We know it will take 2-3 minutes. It stands in the stop. So we program, if you see a train, activate for 5 minutes, for example. If then there is another train coming later, it always reactivates. So if there is another bike coming, it will again reactivate. On each detection, the program and the timer is reactivated.
One more question.
Yes?
From the audience. What is the maximum possible number of light points and controllers? Is there a limit for
There
the
is no
system?
controller. So there is no limit. So it's a scalable system because it's always grouping. LoRa goes about, we propose maximum 800 meters, but it's very rare that you find light points more than 800 meters. I'm now implementing a project in Iceland. They have a road along the ocean, a walking path, 3.2 kilometers, where they will have about 15 light points. They are very separated, but it's just for walking. And there are some benches. So, and we will make a mixture of sensors. So there is, in fact, you can make, if you have a bicycling path of 10 kilometers, it's no problem. And of course, another application, for example, this is a school in France where we have children crossing. So we have a sensor. They have made it a dedicated luminaire. So as soon as we detect somebody, the light is put on to highlight that there is a pedestrian crossing. Okay, if that is for Sensor City, if there are any questions on that. So local for the moment, but mainly not really for...
Thomas, can you please pass the microphone?
Yes.
According to the last slide, like for example, pedestrians crossing, how many meters should be like this person or detect
10 meters,
that object?
yes,
So before 10 meters, the lights will be on.
Yeah. So when it comes in, when it comes in the detection range, in some milliseconds. So this is the detection range of the infrared sensor. So as soon as it comes inside, the lights will go on. The program is started.
And these devices is mounted sensors on the poles. In every pole or
on every pole you would like to control, you need either a sensor or a receiver. So to save money, I have a lake in Iceland, but they decided only to put every 10 poles a sensor, and on the 9 other poles there is a receiver to save some money. The problem is, of course, if you stop in between to smoke or to talk or whatever, so it's a horse riding path and it's a walking path, and you program 3 minutes and you talk 5 minutes, after 3 minutes the light will go down. There is no more detection. So typically in Denmark we have on every light pole we have a sensor.
And how the poles should be prepared for this connection? Like
we need 230 volt and we need connection to the dolly wires. But as I said, it either comes like that, but then you have to make sure that we get 230 volt and we get somewhere a connection to the DALI wires, or it comes with a box. Typically, we use that. So in fact, you see, so the blue ones are the two cables for the power. We take it from elsewhere with the protection, of course, and then from the luminaire, a cable is coming down with the DALI wires. And so the DALI wires are connected here. The Sensicity wires are connected to the orange part. This is typically what we use for Sensicity. So these 4 connectors at the bottom are the wires of the Sensicity, on the top are the power and the DALI wires. But it's not obligatory, but of course we prefer, but we always think that also it's good to have that protected. If you have a lightning or whatever, if we deliver that and there is a lightning and you have the right protection, okay. If of course there is a lightning and you have no protection built in, we cannot be responsible that the lightning will destroy the system. So, okay, yes?
Okay.
There is one more question in the back, or you have one more?
You have one more question, please go.
While the microphone is traveling,
Yeah.
Is it enough communication speed via LoRaWAN? Because LoRaWAN is quite
So
limited.
it's a private LoRa. So I know some cities, they have a LoRaWAN installation into the city that could be used for different. So it's a private LoRaWAN because the communication is very basic. It's just sending a signal, start the program. That's it. So we don't send a lot of data. Also, we don't collect the data. That will change with the connected, because then we have a problem. We will see in the next product. We accumulate data. So there, LoRaWAN indeed, very good remark. That's why we don't recommend LoRaWAN for the Zagas, for example, because more and more data is sent, and this is not built for it. But it's a private LoRaWAN. It doesn't need to. You don't need a LoRaWAN network in the city. You don't pay for it. There is no cost for the communication, so it's all private. So yes, one time you buy this, you buy the dongle. So then somebody of Lucidis will train you how to use it, and then you can very easily yourself program it, change it, whatever you like. It's scalable. If you have more, okay, you have phase 1, phase 2, phase 3, you install them. You go again with your tablet and your dongle. You take the coordinate, the map will expand, and you program in the office. You go back one time to the whole installation, and you say, new program, and they will communicate in LoRaWAN, sending because what do you send? You send what is the boost. It's 80%. When you have a yes, it is 30 seconds. And of course, you have also, let's say, the scheduled dimming, but that's very basic. From that time to that time, you have 10% or 20%.
Okay. Yes, Carlos, please.
Yes, my question is, how do you compete with, for example, Jaga sockets and luminaire controls? Because usually those sockets are installed on the luminaires themselves, and you can do the smart city controlling from there.
Yeah.
But this one is installed especially on the pole itself. So from my point of view, it's like some extra costs. So how do you compete with the Jaga?
I will come back on the next product for the Zaga. As I said, this is mainly on walking and cycling paths, and it's really for non-connected. So you don't need a Zaga. But of course, you don't have control. You cannot monitor the light poles. So that's why I have, again, on this lake in Iceland, I have installed this, but I have installed another solution via power line communication with cabinet control to do the monitoring and to change. In fact, this is mainly used on standalone roads, but it's not connected. So you don't have a Zaga. Typically, you have 2 meter, 3 meter high light poles with a luminaire that is dedicated for pedestrians or for cyclists.
Okay, thank you.
Yeah, but I will come to the next. Okay?
Yep,
Good?
Please, continue.
Good. Now we come, and I will answer now all your questions about that. We come to our most advanced system, which is called Smart Notes. So I'm from Belgium. I started to work for the company Smart Notes, and Smart Notes was acquired in 2019 by Lacroix. And so We were 15 people, and now we are 5,000 people. Small change. But okay, so smart nodes, it's all about the smart node. So what is very important, you will see, we have NEMA or Zaga. I know here that, and I have heard in Lithuania you're more Zaga-minded, and in Latvia you're more NEMA. In Lithuania you're more NEMA, and in Latvia they're more Zaga. We are the same in Belgium. We just have a project where we are delivering 100,000 NEMAs by April next year. So we are shipping now 5,000 NEMAs a month to the Flemish road authorities. But these are the Flemish ones, you know, Belgium, Flemish, French-speaking. But the French-speaking part, they use Zaga. It doesn't matter. We have it all. So it's plug and play, you know it. So you just click it up. It's wireless, and it's very scalable, very important. So we use a mesh connectivity technology called WirePass from Finland. So this is a very advanced mesh connectivity technology, and then we come to the LoRaWAN. It has very high bandwidth and very low latency. So it's really, I call it smart city future-proof, because to be honest, there are very few smart cities already in the world. It's a lot of talk, but it will come. People are adding sensors. Air quality is becoming interesting. Noise is becoming interesting. Traffic counting. It will come, and LoRaWAN is very good if you have few times a day, just saying, for example, in Stavanger, the most popular site is what is the beach water. This is not changing if you report it 2-3 times. So, and scalable, very important. You know that most of the wireless systems, either they have a SIM card, we don't do that, inside the nodes. They have the connectivity and go to a gateway. But then you have starting the problems, how many can you connect? What if the gateway is failing, etc. So WirePass is also allowing dynamic gateway selection. So if one gateway is failing, it will send the data via another one. And we have a solution for that, and this becomes imminent because by June next year there will be 100,000 of these NEMAs installed on the Flemish highways, but they will be crossing. So there is one highway, there is a secondary road on top, and in fact, the problem with mesh connectivity, you don't control where the data is going. We have even seen that we say 175 meters on 1 kilometer. We suddenly had data coming. Okay. Easy to configure.
By the way, one question from the audience. Which cities in the world are smart already? Do you know any which are really smart already?
I think London is pretty advanced. So, but for the rest, a lot are talking. And in fact, on the contrary, a lot have started smart city teams, and a lot of cities have stopped smart city teams inside their administration. Like in Stavanger, in Reykjavik. In Reykjavik even, there is no more smart city team. It all has been taken by the digital department about data management, etc. But all the people working in the smart city team, they stopped. So, but it will come. The same with the smart light poles. So the smart light poles will boost this trend. And that's why, for us, it's very important to be ready. If you now have a LoRaWAN, I think you will not be ready to add a lot of other data into the system. And especially if you would like to add data that you would like to interact. I'm working on a project in Dubai. And if there is an accident, they would activate red lights in the luminaire. This means you need immediate reactivity. You cannot say, oh, after 10 minutes, it's starting red, because then you have another accident. Okay? Okay. Easy configure. So I will come back on that. Also, we have opted, and this is a discussion, to have a GPS inside. So the system is georeference. That means you just click it on, you power it up, and it enters in your system. You don't have to go and ask the electricians, scan a barcode, and then the GPS coordinates. So if you take one node and you put it elsewhere, no problem. It will reconfigure and it will end up in the right place. Cost optimization, of course. So, in fact, you will see on our gateway we have either an Ethernet or a SIM card connection, and there we can go up to 150 nodes. In fact, we are doing the city of Oslo, and there we had to commit to 300 nodes with one gateway, but they're only Zagas, because we also will see we have a sensor node, and this, of course, is generating a lot more data. Very important, we are DALI 2. We are D4I and ZD4I for the Zaga. And our system is Talk V2 certified. For those people working with that, so that's something. So you see, how does it work? You put on a light pole either an EMA or Zaga. We have somewhere a gateway. To be honest, it's shown here on a light pole, 99% are inside the lighting cabinet with an external antenna. Then we connect to the cloud, and then also Lacroix has its own CMS. You know, Talk V2 is a standard, so if you have a Talk V2 CMS, we can easily connect it to our gateway, where we have our own API, but we also have our own CMS, which is called CX Web. We have the gateway, 175 meters communication. This is due to Wirepass. We have NEMA and Zaga, again, 175 meters. And also, we have, in fact, and this is our smart node. This is a very intelligent sensor. So it includes, in fact, a infrared sensor, but also a Doppler radar. That means it measures the speed of what it sees. And so you will see that, in fact, we are very advanced on proposing dynamic lighting. So if we have a pedestrian, we will program 2 light poles before, 2 light poles behind, 40% light, for example, during 1.5 minutes. If at the same place you're coming by the car, you will get 7 light poles before, 200 meters, 80%, but perhaps only 15 seconds. So that's a very advanced system, and of course, you don't need Zaga for that. It includes everything. It's geo-referenced, it has the Wirepass chip, so this is not only detecting, but it's also controlling the light like a Zaga. So all the Zaga functions are embedded over there. Wirepass, as I said, very important, very advanced. It's self-forming. You just add. It's self-healing. If one gateway is not working, it will swap to another one. Of course, with our software, you know that with the management system, we can do the control, different programs. We can do the monitoring. And also, of course, we have the possibility in our management software to do a lot of, let's say, consumption analysis. Very important, if you buy luminaires with D4I, this is now standard. Power consumption measurement is already built inside the luminaire. Don't pay extra anymore to have an extra device measuring the power of the luminaire. And this is all, so I will go very quickly on the power management. You see at the control, this is extracts of our software. Then, of course, we can configure it, we can program, etc., but also we can program the dynamic scheduling. We can do all the monitoring. We have automatic warning for when there is a problem via SMS or via email. We have all the reporting, so you can check on some installations how much did it consume, did it consume last year, etc. Now some use cases. As I said, on the one side, we are focusing on smart lighting, but we really believe in the future smart city developments. And that's why with our system, for example, we have integrated it, and this will be installed next month south of also in Iceland again. So on the road where there were some problems. So we have a pedestrian panel flashing when there is a pedestrian detected that will cross. Because you have these systems already in Belgium, we use it, but it's flashing when there is a car coming. But if you're doing that every day and you never see pedestrians and you're in a hurry, so this is an application. Of course, if you have the sensor, we have traffic and speed information. For some cities, we have it implemented in a residential area, and in fact, they have used it with the police. It's very anonymous. We don't take license plates, but they know that on that day they are speeding, in fact, etc. We have an integration. So this is our gateway. This is our Zaga, by the way. So I didn't bring a NEMA because I was told that Latvia was more Zaga-minded. And this is our gateway. And we have, normally it comes without this. But we have integrated with a Belgian company. We can do noise-controlled dimming. So that means that based on the noise, we can measure it. And all the processing is done inside here. So we can report noise, but also we can take action based on the noise. And it even goes further. We don't only measure the noise, we also can characterize the noise. So for example, there is the spectrum of a gunshot. If there is a gunshot, we can detect it. Of course, in the vicinity, if it can measure it. So it will tell you, well, it's 120 decibels, but that doesn't say anything. But then we can also report it. Typically, our systems is reporting the data every 15 minutes with the mesh connectivity. But we have some emergency features because on the project of 125,000 units on the Flemish highways, they require that when a lamp is breaking down, they want within a second an alarm triggered that they know it is. And so we can add.
So we need to wrap up.
Yeah,
and
that's the last thing I have here. So this is a city, part of a city in Belgium where we have 1,200 light points. And in fact, with smart nodes, you will see we have 4 applications. When there is a white dot, it's a Zaga. When there is a black dot, it's a sensor. The first thing is, this is a 4-lane road going to Brussels. So a lot of traffic in the morning, a lot in the evening, but in the meantime, few. So we have 2 sensors. We have measured the traffic density. And when more cars are coming, we increase the light. In the morning, we put 20%, and we agreed with the city, let's put more. So then we have the other areas. On every junction, there is a sensor. So that means if I'm living over here, all the city will be down. I'm coming here, it will detect me, it will switch on those lights. After a time, I'm living here, so then it will switch on these lights until I'm there. So it's really very optimal use of lighting. This is the city center, and there they have this gateway with a microphone. So that means Saturday evening, people went out to drink, but they make a lot of noise. So, okay, they have decided to put it on 20%, but if we measure 80 decibels, we go up. And then we have a cycling road, which is going to Brussels. People are using it. We are promoting a lot what we call also the bicycle highways. And there we have the dynamic light bulb. So, okay.
Okay. So, thank you for your presentation.
Thank you.
Are there any questions from the audience right now? Because we have some in that, but we will answer them by emails later on.
Yeah.
So, one question from audience, if you have something to ask. If not, then thank you very much.
Thank you.
And round of applause for Frankie. And thank you for Lacroix.